Hello. In this video, we will go over Cramer's rules, volume and area, and go over linear transformation. So this is linear algebra, Cramer's rules, volume, and linear transformation. So you probably learned, you kind of have an introduction to Cramer's rules from college algebra. So we can, so that might be a little bit of review. So let's just go more in depth. So Cramer's rule is just another way to solve a matrix equation of AX equals B and is used in many theoretical calculations. Matrix A is rewritten as AI of vector B matrix by replacing the ith column with the B vector, and I will explain when we do an example. So you can only use Cramer's rule with only in this form, xi equals determinant of AI B all over determinant of A. So basically, square matrix. That's what I really meant. Okay, so imagine this. You have this square matrix A, right? This 2 by 2 matrix. And then you have this matrix, vector X, and that will equal to vector B. So it's what you would do to find to apply the Cramer's rule. To find x1, you basically take the determinant of this mn bd. Yes, mn. So as you can see, what stays the same? The bd stays the same. The only difference is you're going to replace ac with mn. And then it's going to be all over the determinant of A, which is really simple to take the determinant of A, which is like AD minus CB. And then x2 could be y, x1 could be like x, right? And then you take the determinant, and as you can see, the x2 column, this column right here, will be replaced with mn. And then the x1 column, or this column right here, stays as true as AC. So that's you probably remember this from a little bit in college algebra. So so let's do this one. Example says use Cramer's rule to solve the system equation 4x1 plus x2, 6, and 5x1 plus 2x2. Remember, x1 can be x1 can also be expressed as x, and then x2 can be also expressed as y. So what we have to do is first set it up as ax equals. So what would be our matrix A? It's basically the coefficient of x1 and x2. So if you look at it vertically, what is the coefficients of x1 vertically? It would be 4 and 5, right? And what is the coefficients for x2? Looking at it vertically, this has no number here, so that's invisible 1. So it'd be 1 to 2. So this is your matrix A. Let's find x. So x would be our unknown. So our unknowns are x1 and x2. So we'll do that. We'll put that down vertically. So this is x1, x2. And that equals to B, which is your solution 6 of them. Okay, so what we first got to do is, in order to find using Cramer's rule, first we got to find the determinant of A, which is pretty simple. It's a 2 by 2 matrix, right? If it was a 3 by 3, we have to use the cofactors. So let's find step 1, find the determinant of A, which is going to be this number times this. So that would be 4 times 2. minus, and I'm going to put a little bracket, and then it's going to be this number times that number. Okay, and sub a bit. So 4 times 2 is 8, minus 1 times 5 is 5, and then minus, that's 8 minus 5, which is 3. Okay. The next step I would do is found my determinant. I'm running out of space. I'm going to put it a little bit on the side. Okay. So step 2, I'm going to put step 2 right here because I'm running out of space on the bottom. We got to find x1. So how do we set up x1? You're going to replace the fourth. You see this number, 4, 5? You're not going to use 4, 5. Instead, you're going to replace it with your b vector, right? So you're going to replace that with 6, 7. And then 1, 2 stays the same. And then divided by the determinant of a, which we just found is 3. So how do we find the determinant of this? It's pretty simple. 6 is going to be 6 times 2 minus bracket, if you want to use a bracket, times 7. Right, so that's 6 times 2 is 12 minus 7. I believe 12 minus 7 is 5. And then over determinant of a, which is 3. So your x1 is 5/3. Okay, now let's find x2. So it's the same process. The only difference is x2 is like your y. So the 4, 5 stays the same, but you're going to replace 1, 2. This is like your y or your x2 with your b, which is 6, 7. Divided by your divided by determinant of a, which is 3. Okay, so go ahead and clean this up. So this is going to be 4 times 7 minus bracket 5 times 6. All over 3. So 7 times 4 is 28. 28 minus 30 all over 3. So x2 is going to be negative 2/3. Okay, so you found your x1 and your x2. Your x1 is 5/3. Your x2 is negative 2/3 using Cramer's rule. Okay. Let's do another example using Cramer's rule, but it will be like 3 by 3. So remember, Cramer's rule can only be used in square matrices. So a 2 by 2, 3 by 3, 4 by 4, etc. Okay, on this example, it says use Cramer's rule to solve the system. So we have 2x1 plus x2 plus x3 equals 4 minus x1, there's no x2, plus 2x cubed. 2x cubed equals 2. And then 3x1 plus x2 plus 3x cubed equals to negative 2. Okay, so first step is we got to find our matrix A. So we got to set it up as AX equals B. So A is pretty simply, it's just the coefficients of x1, x2, and x3. So if you look at it vertically, starting with x1s, vertically it has a coefficient of 2, negative 1, and 3. x2 vertically, this has invisible 1. There's no number here, so that's 0. x2 has invisible 1. x3, this has no number, so it's invisible 1. X, this one has a 2, and this one has a 3. Times your subscripts, or your x1, x2, x3. This is like your x, y, and z. So this is going to be x1, x2, x3. Your x vector. I mean, yeah, your x vector equals to your b vectors. So your b vectors are your 4, 2, -2. Okay, so this is your matrix A. This is your vector X. This is your vector B. Okay, so let's continue. It's just like the 2 by 2 matrix. The only difference is we're probably going to do cofactors because it's a 3 by 3. So if you recall, let me review. Cofactors have these coefficients: positive, minus, positive, minus, plus, minus, plus, minus, plus. Okay, so this first step is we're going to find the determinant of A. Which is coefficient, so it's going to be 2, -1, 3, 1, 0, 1, 2. Okay, so what are we going to do is, what do you want to do? So you can use any rows or any columns. So let's say I use this column, 1, 0, 1. So this has a coefficient of a negative, because if you look at this, you can use any row or column. So I'm going to use this. So this, you're going to set it up as, so this is a positive one, but according to the cofactors, it should have a minus. So it's going to be -1. And what you have to do is like kind of like visually remove any. So this one right here, you're going to have to visually try to ignore anything that has that row and that column with that one. So what you're doing is like ignore this, ignore this. And then what are you left with? -1, 2, 3, 3. Okay. Okay. This one is a 0. Don't really care. I know it's a positive 0, and I'm not really going to care about this 0 because what's anything times 0, so it doesn't really matter. It's still going to be 0, right? And then we're going to use this one. According to the cofactors, it should have a negative. So ignore this row and then this column. So you're left with 2, 1, -1, 2. You kind of clean this up. It's going to be -1. -1 times 3 is so -1 times 3 minus 2 times 3. I know this is going to be 0 because 0 times anything. And then it's going to be -1, 2 times 2, minus -1 times 1. Altogether, this is going to be 9 plus 0 minus 5. And you get That's not our answer, right? Wait, what we just did? What we just did was we found the determinant of A. That is not our answer. So this is your determinant of A, and it's just more, yeah, I'm going to move it to the side. So what we did was just found determinant of A. So yeah, we just found the determinant of A, which is 4. Now what we got to do is step 2 is find x1, x2, and x3. So x1 is going to be, so what you do is how you set up, uh, you're going to replace the 2, -1, and 3 by the b vector 4, 2, -2, right? So this is going to be 4, 2, 4, and then everything stays the same, right, of matrix A. So this would be 1, 0, 1, 1, 2, 3, all over determinant of A, which is 4. And then you do the same process with x2, right? So go back to your original matrix A, and the only difference is you're going to replace the x2 column with your vector B. So it will be set up as this one is going to be 2, -1, 3. And then you're going to replace the x2 column with the vector B, which is 4, 2, -2. And then the x3, or this column 1, 2, 3 stays the same. And then you divide it by determinant A, which is 4. And then lastly, let's find x3. So x1, x2 stays the same. So this is going to be 2, -1, 3, 1, 0, 1. And then you get 4, 2, -2, all over determinant of A, which is 4. So this, I am going to just help you. I already did this, but you would have to do the same process in order to find determinant of A. Remember, you use your cofactors, and so you can use any row or any column you like. So if you, yeah, use this, and then you have to remember the cofactor signs. So the cofactor signs are plus, minus, plus, negative, plus, minus, plus, right? So I'm going to save you time because I redid it. And this should be -16 over the determinant of A, which is 4. So that spits out -4. Same thing here. When you find the term of this 3 by 3, you should get 52. And then the over determinant of A, which is 4. And over here, this is going to be -4 over determinant of A, which is 4. And then 52 over 4 can be simplified as 13. -4 divided by 4 is -1. Okay, so you just found your solution. X1 is -4. X2 is 13. X3 is -1. Okay, so that is Cramer's rule of a 2 by 2 and 3 by 3. Now let's move on. So application to engineering. Application to engineering many engineering problems can be analyzed by the Laplace transformation, which uses a convenient parameter to rewrite a system of differential equation as linear equation. These coefficients incorporate the parameter. So example, determine the values of the parameter t for which the system has a unique solution and describe the solution. Okay, so determine the values of the parameter t for which the system has a unique solution and describe the solution. So what we have to do is use Cramer's rule, and then the only difference is you see there's a t. Your x1, your x2 won't be like a real number. It will have some kind of t letter in it. Okay. So first step is this is not too bad because it's still a 2 by 2. So let's set it up as ax equals b. So what it would be my matrix A, the coefficient of x1. So looking at it vertically, the coefficient for x1, this one has a 3t. Don't forget about this t, right? That has t. And then this has a 9. And then if you look at it vertically, what are the coefficients of x2? You have that -5. And then don't forget you have a 5t on the bottom. Equals to x1, x2, your vector x. Equals to your vector b, which is 3 and 2. Okay, so this is your matrix A, this is your vector x, and then this is your vector b. So the first step is we got to find the determinant of A. So step 1. Cramer's rule, find the determinant of A. So it's going to be 3. It's a 2 by 2, right? Okay, so let me put it here. So if you multiply this out, so that's going to be 3t, it's 5t, minus, and then if you multiply this out, it's going to be -5 times 9. And boil this out, 3t times 5t would be 15t squared. And then it's going to be minus and the minus becomes positive. And then 9 times -5 is 45. Okay, so we just found the determinant of A. Now let's find x1 and x2. Step 2, find x1. So it's going to be, so what you're going to do is you're going to replace the 3t9 with vector b, which is 3, 2, right? And then you're going to leave the -5 and the 5t alone. Divided by matrix A, determinant of A, which was 15t squared is 45. Okay, let's do x2. So x2, the 3t and the 9 stays the same. The only difference is you're going to replace -5 and 5t with vector b. So it's going to be 3t9, and then you're going to replace this -5 and 5t with vector b, which is 3, 2. all over the determinant of A, which is 15t squared. It's 45. Okay. So when you kind of do the work, 3 times 5t is 15t minus 10. That's 15t plus 10 over 15t squared. X2 is going to be 3t times 2 is 6t minus 9 times 3 is 27. And then this stays the same. And so this is your solution. And then I believe t has no restriction. So you could say where t is all real numbers. Let's move on. So let's talk about the adjunct or adjoint and the inverse formula. So the adjunct or adjoint and inverse formula. So the adjunct is basically the transpose of the cofactors of the matrix, and the inverse can be calculated by A inverse equals 1 over determinant of A times uh, uh, adjunct of A. Okay, so let's talk about the steps. So steps in calculating the adjunct of A. Step 1, for each element, calculate the determinants of the values not on the rows or the columns to make the matrix of minors. What does that mean? You'll see. Step 2, apply the sign. So you've seen this before. Plus, minus, plus, minus, plus, plus, minus, plus, minus, plus, minus, plus. If it's a 2 by 2, the A inverse is basically 1. If you have a 2 by 2 matrix and you want to find the A inverse, it's 1 over determinant of A D negative C negative B over negative B A, right? You flip, you kind of like switch it. And then step 3 to make the inverse. Step 3 to make the inverse, simplify and multiply by 1 over determinant of A by step 3 above. Okay, so let's do an example and let's go over all the steps. So example says compute the adjunct of the given matrix A, and this is a 3 by 3, 3, 2, 0, 0, 0, 1 to negative 2. So recall these numbers 3, 2, 0, 0, 0, 1 to negative 2, 1. You could think of it as the 1, 1, right? Row this number here. If you want to relocate it, that's like basically this 1 means row 1 and this 1 over here means column 1, right? And if you want to locate this 2 here, this could be expressed as C2, second row, first column. And then if you want to locate this 0, it could be found as C31, third row, first column, etc., right? This 0 would be column row 1, column 2, so C12. This zero here is 0, 2, 2, and then this one here would be C32, etc. Right? And then you do the same process for these numbers. This would be C3, C23. So cofactors, yeah, so step one, find deduce step one, determine the element, calculate the determinant of the values of the row. Okay, so I think what we're going to do is we're going to find step one, the cofactors. So this would be and this would be 0 times 1 is 2 times. And then this would be 0 times -2. This would be 2 times 2, 0. Up, you're going to get this matrix. So 0 times 1 minus -2 times 1, that's going to be 2. 0 times 1 minus 2 times 1, that's going to be -2. 0 times -2 minus 2 times 0, that's 0. And then this here would be 2, 3, -10. And then this number here would be 2, would be 0. Okay, then let's do apply the signs. So this is a 3 by 3, so it's going to be plus, minus, plus, minus, plus, minus, plus, minus. So this 2 is going to be still positive 2, according to the sign. This -2, you have to put an extra minus, so that's going to be -2. The 0 stays there, positive 0. This 2 becomes minus. This 3 becomes still positive 3. This 10, you add an extra minus, so it's going to be -10. This 2 becomes a positive 2. This 3 becomes a -3. This is 0. You get 2. This is positive 2, 0, -2, 3, positive 10. And then step three, do the transpose. So what do I mean by transpose? Here, I'll explain. So step three, do the transpose. So the ADG, um, adjecate, ADG stands for adjecate, basically the transpose of this matrix. So what you're really doing is you see this row 2, -2, comma 3. You're gonna make it down, you're gonna come make it down vertically, right? So imagine taking this row 2, -2 and moving it down vertically, and you get 2, -2, +2. And then you do the same process for this row. So imagine this row, um, putting it down vertically, you get 2, 3, -3. And then the same thing with this row here. Imagine putting it down vertically, you get 0 and 0. So the adjecate is going to be this matrix. So this is your final answer. Okay, let's move on. Okay, so this example says, compute the adjecate of the given matrix, then give the inverse. So yeah, in the previous problem the other day, they just wanted to find the adjecate. So in this one, they want to find the adjecate and then find the inverse. So this is a 3 by 3, which I don't really like. It's okay. So we have this matrix A, 1, 2, 0, 1, -2, 1, 3, 1, 0. And what I would do first is step one, find the cofactors. This would be, so it's 1, 1, 2, 2. So that would give me, I get, by this matrix, -1. So I do the cofactors. I get -1, -3, 7, 0, 0, -5, 2, 1, -4, and you do the signs. So basically, how I got those is I use the cofactor, right? basically found the determinant. Uh, yeah, if you need to review that, go look at the previous example, and that's how you got the cofactors. Okay. And then next step is I'm going to do the correct signs. Here, I'm writing space on the bottom, so let's put it on the right. Okay, so step 2 will be the signs. So we have the cofactors -1, -3, 7, 0, 0, -5, 2, 1, -4. And then remember the sign, if this is going to be plus, minus, plus, negative, plus, minus, plus. So now you get this new matrix. So -1 still becomes -1. -3, you had an extra minus, so it's +3. 7 becomes positive. 0, 0, 5. 2, -1, -4. Okay, so that's step 2. Step 3, do the transpose to get your adjective. So imagine using in this row, imagine putting it vertically, putting it down vertically, right? That will be -1, 0, 2. And then imagine using this row and putting it down vertically, you get 3, 0, -1. And then this row, putting it down vertically, you get 7, 5. Okay. And then that's your adjective, but they also wanted to find the inverse. So step 4, to find the inverse, basically 1 over determinant of A times it by the adjective of A. So I think we have the adjective. I just don't think we have the determinant, right? So let's find the determinant of A. So the determinant of A, go back to your original A matrix. Not this matrix, but the original A matrix, you get 1, 2, 0, 1, -2, 1, 3, 1, 0, and since it's 3 by 3, you can use any rows or any columns. So if I use this row, because it has 0, so that was going to make my life easier. This would be 0, and then we would erase this row and this column. I really don't care because 0 times anything is 0, right? And then this, even though this is a plus, this is a positive one. According to the cofactors, this should be a -1. So imagine deleting this row and this column, you're left with 1, 3, 2. And then same thing with the 0. I don't really care about finding the matrix 0. So because anything times 0. So I only care about this. So this is a 2 by 2 matrix. How do you find the determinant of 2 by 2? It's simple. 1 times 1 is 3 times 2. 3 times 2, 1 minus 6, which is negative 5. So you have a minus 1 and then a minus 5, which is positive 5. So, no, I mean, minus 1 times negative 5 is just positive 5. So that means your determinant is 5. So find the inverse. We put it up here. Basically, 1 over determinant of A, which we said was positive 5, times the adjective of A. So the adjective of A was right here. Negative, that matrix, 1, negative 1, 0, 2. This one here. Which is negative 1, 0, 2, B. And if you can leave it like this, or you could distribute that 1/5, and then that'll give us your inverse. Okay. Okay. What we're going to do is quickly go over area and volume, and then linear transformation. So area and volume. So if A is a 2 by 2 matrix, the area of a parallelogram determined by the columns of A is the absolute value of determinant of A. If A is a 3 by 3 matrix, if A is a 3 by 3 matrix, the volume of the parallel pipe determined by the columns of A is the absolute value of the determinant of A. So let's say you had these points 1, 4, 3, 2, 10, 0, and the area would be, so yeah, we have these points 1, 4, 10, 0, 3, 2. The area would be A equals 1. I think this was given. A was 1, 4. Oh, no, that wasn't given. So this is your X, this is your Y, right? So this is your X column, this is your Y column. So 1 is here, and then Y is more here because or you could think of it as this is your X row, this is your Y column, or Y row. So you have an X1, so this is 1, and then over here 3, 2. They use 1, 4, and 3, 2. So you could think of this 1, 3 as your X coordinates, and then this 4, 2 is your Y coordinates, right? So yeah, that's how they got this A matrix. So uh, so if the volume of a parallel pipe determined by the column is the absolute value of determinant of A. So we're lucky that this is a 2 by 2. So how do you find the determinant of a 2 by 2? It would be 1 times 2 minus 3 times 4, and then 2 minus 12 is negative 6, and negative 10. But it's going to be the absolute value. So the area is going to be the absolute value of negative 10, which is positive 10. It makes sense because area doesn't really give you a negative, right? Keynote, when finding the area of one of our points, vertices, negative 10, it must be the origin, 0, 0. So yeah, when finding the area of one of our points, vertices, negative 10 must be the origin, 0, 0. So, so yeah, we must, in order to find the area, you must have one vertices that is 0, 0. We don't have, uh, yeah. So let's look at our next example. It says find the area of a parallelogram whose vertices are listed as 0, -2, 6, -1, -3, 1, and 3, 2. So yeah, we must, little keynote, we must have one vertices that is 0, 0. Since we don't have an origin point, right? We do not have an origin point. What do we do? We must translate it. So, for example, 0 minus -2, 0, -2. In order for this -2 to be 0, must add 2, right? So this would be 0, 0. And then this, you can't just, since you added 2 on the y, you got to do it for all the vertices. You can't just do it for one, right? So 6, -1. If you have to add 2, we're going to get 6, +1. And then -3, 1. You have to add 2. And you get -3, 3. And then 3, 2 to add 2 on the y. So that would be 3, 4. You can pair any, you can, and you can use any pairs besides the origin. Okay, so yeah, so now let's find, uh, yeah, so let's find our matrix A. So it doesn't matter how much pairs, I mean, what pairs you use, as long as it's besides the origin. So you can't use 0, 0. So does that make sense? If you don't have, so you, in order to find the area, you must have an origin, a point that goes through the point 0, 0. If you don't, you're gonna have to manipulate it. So let's, now the next step is find matrix A, and you can use any points you like. So this could be your X row, this could be your Y row, and I'm going to use maybe 6, 1 and 3, 4, right? Or anything you like. So this will be, if this is your X row, this would be 6, 3, and then your Y row would be 1, 4. They will all give you 21. So when you find, so to find the area, basically the absolute value of the determinant of this. So let's find the determinant of this 2 by 2. It's pretty simple, right? 6 times 4 minus 1 times 3. 6 times 4 is 24 minus 3. 24 minus 3 is 21. Or the absolute value 21 is still 21. So we just found the area of this parallelogram. We just found the area of this parallelogram with the given matrices. talk about sumo. This is another example of finding the volume of a parallel pipe. So this time we have it in 3D form. So we have an X, Y, and Z vertices. So find the volume of the parallel pipe with one vertex at the origin, 0, 0, 0, right? Good. So we don't have to like manipulate it. And adjacent vertices at 1, 4, 0. So 1 is like your X, 4 is like your Y, and 0 like your Z. So we are definitely 3D. 2, -2, -5, +2, -1, 2, -1. So fortunately, this is a 3 by 3, so the volume is going to be a little bit more work. The first step, always check if you have an origin point, you do. And then it will be set up like this. So I think you have to use all points. So this is your, you could think of this row, the first row as your X coordinates, the second row your Y coordinates, and then your third row would be your Z coordinates. So it would be set up as 1, -2, -1. So all your X coordinates horizontally. All your Y coordinates horizontally would be 4, -5, 2, and then all your Z coordinates horizontally would be 0, 2. Well, I don't want to take the determinant because you need to know the cofactor. So we need to know our signs, cofactor signs, and plus, minus, plus, minus, plus, minus, plus, minus, plus. Okay, so let's do this carefully. So start with this one. So yeah, maybe I'll use this row because there has a 0, right? Anything with a 0 is good because you can just forget about it. So this one has a positive cofactor, so it's going to be +1. And then if you get rid of anything that has this row or this column of this one, right, you're left with -5, 2, 2, -1. And then this 4 has a negative cofactor, so it's going to be -4. And it's -2, -1, 2, -1. And then this 0, I don't really care. There's 0 times anything, 0. So do the work, you get 1, -5, -1, right? So it's the determinant of this, so it's -5, -1, -2 times 2, -4, and this is going to be -2, -1, minus -1 times 2. And when you do all the work, you should get that the volume is going to be, we actually get a -15, but we know that it's going to be the absolute value, whatever that number is, so it's going to be. So the volume of this parallel pipe with the given vertices is 15. Okay, and then briefly talk about linear transformation, and then we'll just close it off with one example. So linear transformation, uh, let t meaning r square meaning square matrix square. I mean, and this R2 means an 2 by 2, or I think no, actually it means square matrices. Be the linear transformation determined by a 2 by 2 matrix A if S is a parallelogram in R2. Then the area of TS is the absolute value of the determinant of A times the area of S. So yeah, absolute value of determinant A and then times the absolute value of determinant of S. If T is a 3 by 3 matrix A, then yeah, if T is a 3 by 3 matrix, matrix A, and if S is a parallel pipe in XYZ, then the volume of T of S is the same thing. The absolute value of the determinant of A times the volume of S. So let's do what is it? So this example says, let S be the parallelogram determined by the vectors given below. Compute the area of the image of S under the mapping vector X equals to AX, A times vector X. And we are given vector B1, vector B, and matrix A. So vector B1 is 4, -7. Vector B is 0, 1. Matrix A is 7, 1, 2, 1. Okay. Okay, so what we have to do is first find A, which is 7, 1, 2, 1. And vector S is uh, basically B1, mixing just a mixture of 4, B1 and B1 and B. So that would be 4, -7 is 0, 1. So what we need is to find the determinant of A, which is pretty simple because it's a 2 by 2. So that would be 7 times -1 minus 2 times 1. That gives you, this should be positive. That would be 7 minus 2, which is 5. And the determinant of S is a 2 by 2 matrix, which is 4 times 1 minus 0 times -7. So it's just the total area of TS is going to be the determinant of A times the determinant of S. So that's going to be 5 times 4, which is 20. Okay. So yeah, that is all of it for this section. This is linear algebra, and this is an introduction to Cramer's rule, volume, and linear transformation. Stop here.